we're going to look at another type of token called asynchronous token, because what we just looked at is synchronous token. It's called synchronous because it's synced up. The token and the authentication server is synced up. Now it could be synced up on time, which is what I just went through, or it could be synced up on event. And like I said, if it's event, then let's say I have a token, it has a button. What happens is I push that button and a new number is shown to me. Then that value is my one-time password. I put in my identification number, I put in this one-time password value, it goes over to the authentication server, and the authentication server and the device, the token, they have the same list of numbers. So when I authenticate the first time, I'm going to send over the first value. The authentication server is going to be looking for that first value. When I push the button, that's the event, it goes to the second value. So my username and that second value is my one-time password. It goes over to the authentication server, which knows to go down to the second value. So that's what it means by event. Now, because we can't seem to call an apple, a lot of times we have more than one name for one thing. Event can also be called counter. It could be a counter token device, and you could see that on the exam. You could see synchronize, you could see event, or you could see counter. So event and counter are actually the same things, they're just two different labels. Now that's synchronous, and I'm going to explain how the asynchronous token works, but let's take a minute and understand how challenge response authentication happens, because I find that not everybody knows how that takes place. So let's say I need to, and I'm stepping outside of a token device right now. I'm just talking about regular challenge response. It's in a lot of different protocols that we use today. So I need to authenticate, let's say, to my ISP to get on the internet. And it uses an authentication protocol like CHAP, Challenge Handshake. So it's going to challenge me. So I need to authenticate to the ISP. What I'm going to do is I'm going to send over my username. My system is going to send over my username, and then at the ISP, the authentication server, is going to look up in its database and see if it has a Sean Harris. If it does, it knows what my password is. It takes this password and it uses it as a key for encryption. It takes a value, some random value, which is called a challenge. It encrypts it with my password and it sends it back to my system. Now, if I've typed in my correct password, it will decrypt that challenge, and then I'm authenticated. Now, let me say one more time. When you put in your username and password, you don't realize what's actually going on at the protocol level. So you put in your username and password, and what's happening is your username goes over to the authentication database. The authentication database looks for your name and an account. It finds Sean Harris, it looks at my password, which is just a value. It's just, it's in binary. So it takes a random number, which is called a challenge. It takes my password and it uses it as a key to encrypt the challenge. Then the challenge comes back to my system, and I have put in my password. If I've put in the correct password, my system takes my password and decrypts that challenge and sends it back to the authentication server. So this is what challenge response authentication means. And the benefit is that you're not sending your password over the line. You're just sending your username. Your password is used as a key to encrypt a value that's coming back to you.